Hi everyone, we are back for another talk. We are coming to the last talks of the day. This is the second to last talk, unfortunately. I hope you're enjoying the conference. We certainly are enjoying the conference ourselves. We have an amazing lineup, such cool speakers, and this talk is not an exception. In this talk, we're going to talk about fuzzing. Well, not me, but the speaker is going to talk about fuzzing, which is something that I'm quite sure most people in the audience has had at some point in time some experience with. It's a great way, a practical way to find buggy code or flaws in your code. And our next speaker is going to tell us how we can integrate this different fuzzing strategies into our testing strategy in the best efficient way. So let me introduce to you Melissa Benua.
Hello everybody, I'm excited to be here and talk to you today about fuzz testing. So fuzz testing is one of probably the favorite things I've done over the course of my career. And so I started many years ago as an SDET at Microsoft. Now I am a director of engineering at mParticle. I've done a little bit of everything. But like I said, when I was an SDET and then a developer working on Bing was one of my very favorite things because I had so much freedom to explore. And one of the very first things that I ever explored was this thing called the forking service. So I'm going to be very careful here throughout this talk while I talk about the forking service because it was known by a lot of different names, as you might guess. Sometimes it was known as that forking service when it annoyed devs and brought down traffic. Sometimes it was also called that service that forked all my test environments. But you get the idea about my forking service. And so what it did was something that's also known as traffic teeing. The basics of it is that it would send actual copies of sanitized production traffic from production, make a copy of it, and then federate it out across a couple of different parallel production environments in order to validate that the services were operating correctly under prod-like conditions with prod-like traffic. I know what you're thinking. Of course, there was anonymization in place. We were always very careful not to be leaking customer data from production into our test environments. Also, this was many years ago. They have moved on beyond this. But anyway, so when I joined Bing, I didn't invent this forking service. But when I joined, it was already considered a pretty critical part of the whole release process. If a release candidate could go 24 to 48 hours without any crashes or any memory leaks or any weird metrics, then the code was probably able to be considered stable enough for production. But obviously there were still issues that were missed. And I wanted to know, how could I take this data, this very good production-like data, and how could I use it to drive out any more issues? So at the time, we had an internal security team who was publishing, internal to Microsoft, who published a set of fuzzing libraries, especially with attacks. And this library was pretty cool. It was, I was able to access the source code to it. It was in C++, and I worked in .NET, not a big deal. But I thought, well, if they've already got, put together this expertise to create this library of attacks, I wonder how I could apply these libraries on top of the pretty good data that we already have, and then combine that also with the model of our domain-specific HTTP traffic and create a thing called the fuzzing service. And so the fuzzing service was just the forking service, but with a layer of fuzzing applied on top and able to run at scale as well. So basically it would just take our existing good traffic and inject an excess attack into it, anything that you could think of. It had some security-specific attacks, some non-security-specific attacks. We'll talk more about what those look like in a minute. But it would just transform our traffic into something exciting. And so let me tell you. So the first time I turned it on, I was sitting at my desk and I was typing, and I sent everybody an email and said, hey, the release for, the next release that's coming up, just know if you see anything weird on the test beds that I've turned on this small fuzzing addition to your fork traffic. I don't think it should cause any problems. I'm not concerned about it with the release, but just let me know if there's an issue. Then I locked my desk, got up and went and grabbed a tea. And as I was walking back down the hallways, I could hear this forking service. What the heck happened with the forking service? The beds are down. I could hear complaints popping up all up and down the hallways. And so by the time I got back to my desk, I had a bunch of red bang emails saying, what did you do? Why are all the beds down? Can you make it stop? So I sort of scrambled and turned the traffic off. And lo and behold, when we started triaging, there were something like 8 different crashing bugs in code that had been running stably under production like traffic for days to weeks. There were these 8 different bugs that were brand new crashes. And so the devs, of course, scrambled to fix them in order to save the release. Fixed them, got them out again, and then the request came in, hey, can you, Melissa, please put that Fuzz traffic back on? We want to validate our fixes. So I said, sure, okay. I turned the traffic back on, and within 10 minutes, all the beds were down again. And so I turned it back off, and after those 8 crashing issues had been fixed, there were a few more to be driven out. They had been less frequent than the earlier crashes, but they were still crashes. And a lot of these were crashes that were in production already. They weren't even in net new code. So there's more scrambling and more fixing. We turned it back on again, and this time the beds didn't crash for a while until they ran out of memory. Because it turned out we had driven out some memory leaks as well. And so once the machines were stable enough to run for 7, 8, 9, 10 hours, we could see their memory ramp was doing that, and that they had memory leaks in them. So again, there was more frantic fixes going out. I don't remember exactly how long it took for us to stabilize the beds again, but there were more than a dozen bugs in code that had been living in production, some of it for years. Some of them were very old, weird ghost crashes that would happen, 1 in 100 million requests. We had no idea. Nobody's going to chase down that. Nobody's got time. That we were able to reproduce very quickly with the fuzzer. And we had issues all over the place. We had issues in our C++ web service. We had JavaScript vulnerabilities rendering on the page. We had memory leaks. We had crashes. We had deadlocks. We had actual vulnerabilities. And we found all of these things just by making our traffic look really, really weird. And we had at least one pretty nasty bug in there. There was one buffer overflow that was causing cross-process memory contamination that took hours to track down and fix. And who knows what would have happened if that bug had actually made it live into production. There were all kinds of really serious, interesting issues that we found with fuzzing that we wouldn't have never found. No human would have ever come up with the combinations, doesn't matter how many, doesn't matter how many teams we put on it. We never would have found it. So let's back up a step here. And let's lay down some definitions. So what exactly is fuzzing? So the definition of fuzzing is just generating random inputs to explore the bounds of a system under test. And these are my definitions that I'm going to work with here. I'm sure if you're looking online, you may see slightly different definitions, but they should be pretty standard here. So the fuzz testing is just to explore the boundaries of our system that's under test so that we can understand what it's doing and figure out all kinds of interesting test cases we wouldn't have come up with on our own. So what is an attack? So you hear me talk about an attack. An attack is a specific type of data meant to drive out a very specific class of bugs. So you may have an XSS attack. You may have a XSRF attack. You may have a SQL injection attack. You may just have a buffer overflow attack, right? It's designed to cause some specific type of vulnerability or bug. A manipulation, which we'll talk about, is going to be the combination of an input with an attack. So taking your known good input or known bad input and then layering an attack upon it. And then there's 3 specific types of manipulations we're going to talk about. The first is a creation manipulation, which is just a de novo generated input inserted in place of your text. So imagine if you have the value of a header and it goes from, your accept header being application JSON to semicolon drop tables. Meanwhile, an insertion manipulation would be modifying a known input to include an attack. So in the example of our header, we might have application /j semicolon drop tables son. And finally, a genetic manipulation is successively modifying an input based on system behavior. And we're not going to talk about that too much today because that's kind of a solved problem. So if you have the ability to monitor coverage, right, to monitor branch coverage of your application, then you can do genetic manipulation to continue to explore all of the branches. And that's what things like fuzzy lop do, is they allow you to, they have insight into what they're accessing, and they can intelligently modify the inputs for successive attacks to try to drive all the way through your code. So what are the keys to a successful fuzzing run? So you've got to have a model, right? We'll look at what models look like. You have to have the attack set, which is some of what we just talked about. And you have to have a plan. And so your model is what you care about, right? If you are on the HTTP level, your model is the HTTP model. If your application has some JSON, your model is whatever you're defined in JSON. The attack set is all of the bad things you're going to do to yourself. And your plan is how you're going to apply that attack set intelligently to your model to get the best bang for your buck. So the first thing we're going to want to do here is define our data model. Because again, if we're talking about, if you're talking about a simple input-output program, if you're talking about something that's command line based, there's tools for you. You're not going to need to define or invent anything here. You can just go grab AFL, hook it up. It'll just walk through your application, and you're solved. You're good to go. But if you're talking a service, if you're talking something with a highly structured input model, if you're talking something that can't be easily watched for coverage, which not every language and application lends itself to do so, you're going to want to be very crisp about defining your data model so that you can customize what you're going to do next to your specific input case. And every piece of data is going to have a model, right? We don't just have unstructured data. Nobody runs a service that way. So if we're talking HTTP, for example, there's a data model here, right? HTTP always contains these pieces. HTTP, right, has a method, it has a URI, and that URI has a specific format. And in that format is, for example, query parameters. Query parameters also have a separate format, which is separate from the format of the overall URI. Likewise, headers, right, or key value pairs, they have a format. Some headers are comma separated, but if you get down into the cookie header, for example, it's actually a totally different format, right? It's semicolon and ampersand separated. And so the important thing about defining our models, we need to know what's important to us, right? If I'm interested and I'm running an application at the HTTP layer that has, say it's reading data off of query parameters, I'm not particularly interested in fuzzing my web server. Not because there couldn't be vulnerabilities in my web server, of course there could. But that's not my job, right? If I work for company X, I'm supposed to be testing and validating company X's application. It's not as much of interest to me to make sure that if I'm running on Apache, that Apache's done their due diligence in making sure their service is secure. And I'm not saying nobody should be testing Apache. I'm saying it may not be your primary job to ensure that Apache works right. Your primary job is validating that your application is behaving as it's supposed to. It's not a good use of my time to be dealing with Apache at the TCP level if my application is JSON layered over HTTP. And so the first part is understanding the fundamentals of your data model, and then understanding what your application is going to do with that data model and the specifics of it. So for example, if we actually are reading JSON post bodies on top of HTTP, then that's going to define what's actually of interest to us. And more specifically, it's going to define what is not of interest to us. Because if I'm on JSON on HTTP, then I don't really care about XML vulnerabilities. If I'm a purely NoSQL shop, I'm not going to be all that worried about Oracle DB vulnerabilities injected in either, because it's not likely to be relevant to me. So understanding your data model and understanding your risk layer is going to be a big deal in helping you figure out what's going to be really important, right? JSON also has a format all its own. JSON has, specific layering of parentheses and quotes, and then your application is probably going to have a specific type of data model layered on top of that again, right? It's going to have required fields, optional fields. It's going to have the structures of those fields. This one is an int. This one is a string. This one is an array of objects. You're going to have your own specific things that you're going to want to test for. And so with that in mind, we're going to want to be very cognizant of our attack selection. And so attack selection is a fun thing. And it's sort of a solved problem. When I say a solved problem, I don't mean that new attacks aren't being invented all the time, because they are. I just mean that if you find that you are having to invent attacks, you should stop and look around. For example, I'm going to show you all some sample code later that uses FuzzDB, which is an open source solution to generate attacks out of. My full-time job is not investigating and exploiting vulnerabilities. That's some people's full-time jobs, and that's an awesome job, but those are the people who should be then helping to craft attacks. My job is helping to take those attacks and apply them at scale to ensure that my services are behaving as well as can be expected. So lots of things can be attacks, right? Of course, SQL injection, everybody wants to drop tables. That's the old best standby. But control characters are also an interesting attack. Just this piece here, you don't want to know that I basically crashed PowerPoint twice trying to put it in, right? I fuzzed PowerPoint for them. They're welcome. XSS, obviously, it's a set of attacks. More useful if you're going to be rendering in JavaScript in some way or the other, but it can be a useful set of attacks. Integer overflows, redirect attacks, but don't neglect the benefit of trying to do buffer overflows with just some random strings. You'll see a little bit later that the most mileage out of any attack I've ever gotten has just been a lot of A's. And I don't mean, the 7 or 8 A's that are on the screen, which is fine. But 20,000 A's, 50,000 A's, 128,000 A's, lots and lots of A's, will start to tell you very interesting things about where you may have buffer overflows, where you're not cleaning up buffers, where you may get very interesting emergent behaviors, where things are, if you're in a managed language, where you may be pushing something into garbage collection, you're going to be vulnerable to being DDoSed. Or just DOSed, for that matter. You can get a lot of mileage out of some very, very simple attack test cases. So we've got our attacks, we've got our data model. And so great, let's generate a fuzz request. And so this one to some random website is fuzzed, and it is, it's very fuzzed, but it's not going to be very useful for testing. And why is that? For a number of reasons. It's so fuzzed that it's unlikely to go anywhere useful. It's unlikely to even leave the machine upon which you're trying to generate traffic from, much less go to the machine that you care about, much less trigger the application upon that machine that you care about. Right? For one part, the verb is messed up. And for another, URI also is not correct. So you're not going to go to the endpoint you even wanted to get to begin with. And even if you did, we've injected an attack into our path. So if we're testing a specific feature under our application, we're just going to get 404'd. If you're testing the 404, that's great, but if you're not testing the 404, then that's not going to be all that useful to you. Likewise, we're missing headers altogether. Our cookie header is gone. So if we care about the data in the cookie header, well, that's not going to go anywhere useful again. We're still, it's basically a wasted test case. So without a plan, your fuzzing is going to be extremely scattershot. It's not likely to get anywhere useful. You're going to have to spend a ton of requests trying to get, a small fraction of them even to be acceptable enough to hit the application under test, never mind actually do anything interesting to it. If you fuzz too many things, it's going to be difficult to find a repro. You're going to have a lot of things that are just summarily rejected because they don't even get to the application that you're interested in. Meanwhile, if you don't fuzz enough things, right? If you fuzz, one teeny tiny thing at a time, it may take too long to get a repro for anything, right? One crash out of 100 million is unlikely to be something that gets investigated. And so what you need to do is you need to make a plan. So a plan can be pretty simple. Here we have a very simple example of a plan for fuzzing an HTTP request. So it says, the basics here, we want no more than 3 attacks, we want to use a specific attack set, we want to fuzz our method very infrequently. Because remember, I'm not saying you should never fuzz your web server, but it shouldn't be the primary goal of your operation here. So we want to fuzz the method, but very rarely. We never want to fuzz the host header, because if we fuzz the host header, then we're not going to get any routing. It's not going to go where it needs to go. In this specific case, obviously there's ways around that. We don't really want to fuzz our path that much either, because we're trying to test a specific subpath. We want to fuzz our query line like crazy. Let's say we know our application, we know that the path is not that interesting, the host is not that interesting, but the things on the query line are extremely interesting. So we want to fuzz those like crazy. Likewise, we'll take a look at our headers, right? We don't want to fuzz necessarily the name of the header, because if we fuzz the name of the header, as we all know, that's just a key value pair dictionary. Again, it's not going to be that interesting. But fuzzing the values of that headers could be very interesting, especially our authorization header. If we need to be logged in and we never want to get rid of the authorization header altogether, but sometimes we may want to fuzz it. We don't want to fuzz it as frequently as the other things, because we're fuzzing, our authorization system. And so if we know for a fact that if we don't auth, then we can't access the rest of our requests, then we don't want to do it that often, right? It's not the most important thing we could be checking. We know it's going to be an artificial limiter on the amount of traffic that gets to somewhere interesting. And so if we take a well-crafted plan and we apply it here, all of a sudden an interesting request emerges. So take this one. This is very likely to get where it needs to go. It's got the right method, it's got the right host name, it's got the right path. And we've injected, pretend there's more A's there because my screen is only so big. We've injected some A's into potentially an interesting field on the query line. Likewise, we've fuzzed one of the cookies. We fuzzed it in a very interesting way. Especially if you have awareness of how your application is using cookies, you may know that, this part of the application has this, this cookie layout, and this cookie, for example, I know is always used as a user identifier, and sometimes it shows up, right? Sometimes it shows up on a JavaScript page. That's interesting, right? Using your knowledge of your system to help guide the fuzzer so that it can generate attacks well beyond what your knowledge and creativity could come up is the key to crashing your application 12 times in an hour. Right? This is also a very good fuzzed request. It's respecting, first and foremost, that we have to authorize or nothing's going to happen. You're just going to be testing your authorization handler. It's going, again, to the right URL with the right method. And it's, most importantly, it's JSON aware. Right? If you notice, we don't want to fuzz our JSON parser, which, could be interesting sometimes, but that's not usually the most interesting thing we could do. And so this is a JSON-aware fuzzed output that says, this is a number, great, I've inserted integer.max. Or, this is a string, great, I've injected some extra XSS into the string. And so this request is also very likely to cause some very interesting behavior, if there's interesting code to be explored. Much more interesting than if you're trying to fuzz, Newtonsoft JSON parser. And so let's say you've got your attack set, you've got your plan, you've got your data model. Now the next and most important thing is knowing that you've actually found something. This is actually a pretty hard problem, and if it's something beyond just a straight up crash and a bunch of core dumps, it can be quite tricky to know that you've found something interesting with your fuzzer. There's a little bit of an art. So first of all, it involves knowing what your baseline metrics look like, right? What do your metrics look like in production? What does a deviation from those metrics look like? Especially memory usage, that's a big one. And then being able to isolate and reproduce down to see, do we have an actual memory leak, or is it just that we've allocated more buffers and so we're using more memory? Right? Because those are both are potentially valid, and both may look the same in your metrics to an untrained eye. Likewise, being able to scan through your logs, look for anomalous log readouts, especially if you've got really good logging or observability wired in. You can also look for side effects. That's especially good when you're trying to do, if you've got a bunch of SQL injections or you've got a bunch of XSS. Right? XSS is unlikely to crash your box. SQL injection may or may not, right? Can be hard. But you can craft your fuzzer with side effects so that you know if a certain table gets written to, well, then there was a successful SQL injection. Or if you log a specific message, only if you manage to trigger an XSS exploit. So you can craft side effects or hooks. And once you've got those, you could also use an oracle to help you figure out what was good and what was bad. An oracle is just an automated way of making judgment calls about the things you found in case you don't want to spend the rest of your life staring at a dashboard of graph go up, graph go down, and entailing log lines like you're in the Matrix. So the oracle will help you set thresholds and alerts that says, this is bad, right? Memory ramp like this is okay. Memory ramp like this is not okay. A human needs to go look. So we talked a little bit about how you can find it, and here's some of the things you can find. And these are things that I have over the many years of my career. These are things I have actually found. I found lots of crashes. Whether it's buffer overflow or just top level exceptions, depending on your language set. I found crashes du jour, so many crashes. Also a lot of memory problems both because you're doing large allocations and also because you're doing strange allocations. You can find leaks. You can also find thread contaminations, right? Buffer overflows. You can find actual exploits, right? You can find SQL injection, XSS code injection, redirect. You can find all kinds of exploits with some well-crafted fuzz attacks. So there is, if you're interested, there is an open source repo that's at this GitHub link, and I'll post about it as well in the chat. It's .NET Core based. It's extremely lightweight. It's a library that's meant to be used to make it very easy to define your data model. We use it actually as a part of unit testing because it has reusable seeds, so you can generate the same seed and have reusable test case runs. But there's a simple fuzzing library that you can use. It's open source. You're welcome to contribute, play around with it. No problems. And we are going actually to take a look at what that looks like. So here, let's see here. There we go. Here is our fuzzer. And so you can see here, we've got a very simple program that's using the fuzzing library to define a data model. And I apologize, it's maybe a little small. There we go. So you can see here that we have a very simple default strategy, which is the plan we're going to use to fuzz this HTTP, this very simple HTTP method. Simple HTTP message. We're not fuzzing the method. We're going to set some very simple probabilities, define our model. We're going to send some requests here. So let's actually take a look at that. So here we go. We've generated some very simple requests, just a random website on the internet, just, whatever. You can see they're extremely simple. They've got a count on them. They've got a query line. They got some headers, got a cookie, but it's a really simple cookie. So great. Now we're going to fuzz them. So we generated some A's. This is a random seed, so every run is different. Never know what you're going to get. But it looks like it did a pretty good job here. You can see we fuzzed within the accept encoding header, so it's still a valid header. It just has this, I'm not sure what attack it is, but it's definitely a FuzzDB attack injected in here. We can also see that there's so many A's, and it's got, oh look, there's a XSS vulnerability in here. Looks like, so this is one request here. And we can see the query line is massive with some additional injections in there. See if we can find anything else interesting in here. So many A's, it's full of A's. Here we can see there looks like there's a SQL vulnerability in here. XSS alert in here. But for the most part, the requests are actually pretty well formed. They're just full of A's. So if we were to actually send these requests, come on you, all the way down. Where did you go here? If we're going to actually send these requests now, here we go. 2 of them had bad paths. One of them, it's interesting, right? URI too long. That's an interesting test case. And then 2 of them 503'd. And so if we want to change our seed, you can see something else happen. Here we go. We're going to fuzz some new requests. Maybe we'll see less A's. Yeah, see less A's here. So let's see what happened here. Let's see, this one might not have had anything bad happen to it. This one did. Right, we got a very modest amount of A's injected in here. Interesting things happen. So if we send these requests, totally different thing, right? Probably one of them had their path found and the other ones were accepted. The other ones were okay. And so imagine this reproduced not over, 5 requests at a time, 5 requests per second. Right? 5 requests per second is 300 requests per minute. I'm not going to keep doing math here, but you can see how this can add up very quickly when you're fuzzing at scale. So now imagine not 5 requests per second, but 50 requests per second. That's 30,000 test cases per minute. That's a lot of room for A's. That's a lot of room for vulnerabilities, but more importantly, you have the scale in order to drive out interesting behavior. Because oftentimes bugs are not just dependent upon a bad code path, but driving them out can be a combination of a bad code path at scale, right? Especially when you've got multi-threading going on. And you've got interactions of, thread deadlocks. You've got interactions with different threads, one against the other. You've got memory cross-contamination. All of those things are much, much more interesting when you're operating at some sort of scale. Memory pressure, CPU pressure, etc. So that's a very simple fuzzer. Does very simple things. Yeah, so if you want to explore a little more, of course, you're welcome to go grab that repo. But likewise, there are some other further reading hints here for you. The fuzzing book is actually a really great entry-level introduction to fuzzing. Uses a lot of Python, uses a lot of actual code examples in Python, walks you through sort of setting up fuzzing from beginning to end. You heard me mention AFL before, American Fuzzy Lop. I believe Google took it over. Yeah, Google's got it. Uses code coverage for genetic algorithms. Really great if you've got an input-output based application or a single box application, especially one in a language that it can parse, mostly C. Fantastic, solve your problem. You don't need me for that. You can just go grab the tool and install it and run with it. FuzzDB is actually where my dictionary of useful attacks came from, and I will show you a little bit about what that looks like here. And so FuzzDB is an open source set of things. So for example, it's just a list of proven vulnerabilities. So for example, here's a set of things that have been proven to cause problems in MongoDB. Likewise, here is some DB2 SQL injection, MySQL local file read vulnerabilities. Here's some good old XSS. Should look pretty familiar to anybody who's ever played with XSS even once. This is standard. But yeah, so that's FuzzDB. Free for anybody to go and look up attacks that have been proven to be useful. Likewise, on BlackArc, there's a list of fuzz testing. And of course, if you use Kali, Kali has lots and lots of built-in security tools, several of which are to enable you to do fuzzing on your own, whether that's via a proxy or a couple other tools. There's a bunch of stuff on there that's useful. So let's see here. That's about it. Thank you all so much. I'm excited to answer questions. We can deep dive through some code. I've got no problems showing code or showing some more test cases. We can run some more fuzzing passes.
We are back here. I told you this was going to be a very interesting talk, and now is the time for Q&A. So let me welcome Melissa.
Hi, thank you. Hopefully everybody enjoyed.
Yes, we already have some questions, like, is your sample code in C#?
Yes, the sample code is in C#. The library itself is in .NET Standard 2.1, so it's compatible with .NET Core or .NET Framework.
I loved your talk. We were talking backstage that it's so interesting, so technical, and you are you explain very well what you're doing. So it was amazing. So I want to thank you publicly again once more for everything that you're doing for us and for participating of NotPinCon. For the audience, if you have any questions, again, you can post them in here in Twitch or using our Discord channel. So I'm gonna be waiting for those questions in case you want to ask Melissa something. So
yeah, thank you, first for having me. I was really excited to to speak today. I love talking about fuzzing. I don't get to do nearly as much as I used to once upon a time when I wrote a lot of code in my day job.
Yeah, so it's so interesting, and I think it's so interesting to talk about. I'm sorry, it's very interesting to talk about security when it comes to development, because there's so much improvement that we have to apply yet for many companies and developers that don't take security into account. So it's good to create awareness in public events like this one about how you can secure your code and find different flaws using very, I think, intuitive tools. That's up for discussion. So I'm not sure that the audience thinks the same, but they are very easy to use. And following your methodology, you can integrate this testing tools to the testing strategy that you have already implemented. So it's a public service that you're doing here to securing apps everywhere.
Yes, I'm a huge fan of integrating testing and security as part of the first party process of getting code out with the rest of the development pipeline. Like in the CI/CD talk earlier, right? Everything that I do and that my teams do has to happen as a part of the CI/CD pipeline. It has to happen as early as possible. So security, right, happens built into the CI/CD pipeline. Happens certainly no later than code building, but earlier the better. The same with all testing, right? Security is a type of testing.
Exactly, totally. We have a question here. How did you get started in fuzzing? You are truly a queen of code, as your Twitter handle says. So you have so much experience. Perhaps you can tell us something about your journey towards fuzzing.
Yeah, so I started with fuzzing by actually going to a talk. It was an internal company talk presenting what fuzzing was and presenting, the types of things that you could find with fuzzing. Very similar to my talk, but given 10 years ago. And so from there, I found some resources and I explored with it. I made a proposal to my manager at the time that I was responsible for this system, and I wanted to do an experiment to see what would happen. And that's the basis for the tool that we talked about, that I talked about first today. So I just started with learning a little bit and then experimenting, and that's pretty much how I've started with everything, which is learn a little bit and then experiment, and then you learn a little more.
That's a great advice. Someone here is asking for the link on GitHub for the sample code. So someone shared it afterwards. But if you have any other resource that you want to share, you can do it later on the Discord channel via text. We have some people are writing questions right now, so let me wait.
Paste the or they already got it. Never mind. Yes, you're fast.
If you come next year to NotPinkCon, we will gift you a T-shirt full of AAAs.
I would be delighted to come next year to NotPinkCon.
We would be delighted to have you back.
Yes, those of you, I'm sure nobody knows, my family is from Buenos Aires, so I'm always happy to come. Please don't make me give my buzzing talk in Spanish. You won't like it.
It's better than my English, that's for sure.
No.
I'm doing my best.
You're doing much better than I would be doing in Spanish, I promise.
Okay, we have another question. What is your opinion on CISP certifications?
That is a good question. I am not a good person to give an answer. I don't tend to evaluate people based on their certifications. I tend to give more practical tests when I'm hiring, so I cannot give you an opinion either way. I know lots of people feel very strongly about certifications.
Yeah, I know, and it's kind of like a trend. I see people are obsessed with certifications, security certifications, but there are other types of courses and certifications that are so much more interesting, perhaps, than security ones. But I'm talking about myself. It's
I kind of predate certification. Right, when I was coming up and starting in the industry, certifications were not. It was different than it is now, so. It wasn't a thing for me, so I'm just not as fluent with the needs of a certification.
Yes, totally, I get it. Some people are kind of obsessed with them. There are other ways to prove knowledge.
Yeah, there's lots of ways to prove knowledge. You can do the certification route. You can do the open source repo route. You can do just proving it in an interview route. There's lots of different ways.
Totally, I agree. We have another question here. Are there any online platforms for learning that you recommend?
Online platforms for learning. So it sort of depends on how you like to learn. So I will say my friend Tanya Janka has She Hacks Purple is her Twitter account. She has a website, I think it's called wehackpurple.dev, that she's putting together a learning platform specifically for people who want to get into InfoSec. So I definitely approve of that, and not just because I was on her podcast the other day. And that's a pretty good place to start. She's got a lot of good resources for people who want to start in InfoSec. Otherwise, I just tend to float around and see what talks are being recommended out of my network, because it changes so quickly as a field that the platform that was the best platform last year is not the best platform this year.
Oh, totally.
Very much a moving target.
Right?
Nothing was on Twitch like this a year ago.
Yes, totally. I totally agree. The technology changes so fast. If you feel free, you feel free to share those links afterwards in our Discord channel, because I'm sure many of these people in the audience are really very interested in checking them out.
Yes, I will put those in the Discord.
Does anybody else have a question? Yes, someone says so. Yes, please. Exactly. Everybody's asking for links. So yes, we will share them with you.
Yes, I will share them, I promise.
Okay, Melissa, it has been so good to have you here. Thank you again. We are so grateful for your talk. You have made this event even better. You and all the speakers, we are so thankful. So if you have anything else to say, if you want to comment on fuzzing something else, feel free to do it. Otherwise, we just want to thank you for your participation. And I think that'll be all.
Yeah, thanks a lot. If you're interested, of course, to learn more, there's the GitHub repo is open source. Feel free to open issues or make pull requests or just make commentary. And I'll see you all in the Discord.
Great, we will. So I'll leave the audience and and every one of you with Sheila next, because we have the last talk coming on. Unfortunately, this event is coming to an end.